Hi, in this video we're going to learn how to use some basic R summarization commands and making graphs, and you'll use these throughout the course. The files I'm starting with are in the Getting Started with Statistics in R module of Canvas. It's these data summarization RMD markdown file, and this is the processed one that we will produce when we're finished. I believe these files will also be placed in the next module under distributions, so you can probably find them in both places. Remember, to get these this markdown file into RStudio, what you need to do is click on it and download it, save it to your downloads folder. So you save it. And then in RStudio, you go to your upload button and browse to the downloads, your downloads folder. It's also sitting in here in this file, so I'll just bring that up. And it will appear in my files area, and I'll open it. And let's have a look at it. It's called Data Summarization in R. It's going to make an HTML file. We're going to need the knitr, ggplot, and tidyverse packages. And I believe if you've been following along, you've already installed these. The extra package we're going to need for the data is called the Gapminder package. And remember, you probably don't have this one installed yet. So to get it installed, what you need to do is go to Packages, choose Install, click on Gapminder, and click on Install, and it'll install that package for you. And then we're ready to start. Remember, you can process code blocks one at a time with just clicking on the Run Current Chunk. These first lines from 10 to 13 have run. Line 22, we can run that one. And then in line 28, this means that we're going to have a glimpse or look at what's in the Gapminder data frame. This stuff on the beginning means it's coming from a package called dplyr, and it gives the package name and then : the command that comes from that package. Now dplyr has already been loaded automatically when you invoke tidyverse up here in line 13, but I'm showing this to you in case it occurs other places in the course. We have a package name, : and then the function that comes from that package. And if we click on that, we'll see what's in this data file. And we can see that there is going to be countries, what continent they're from, year the data is from, life expectancy in years, the population in the country, and the GDP per capita, the per person income in that country. And there's 6 variables and 1,704 observations. If you want to look at the data a little bit differently, you can use the head command. You might have seen me use that already in the course. This will, without any arguments, head and the data frame will show the first 6 rows. So the first 6 rows are all for Afghanistan, the information about Afghanistan over the years 1952 up to 1977. My next head command shows you that you can change how many rows you want to display. So I changed from the default of 6 down to 4 rows, and so you can see the top of that data frame as well. Remember that as you're working your way through the file, you can take away anything that's been displayed by clicking on the X, and it'll remove the part of the display. The next command in line 46 is a basic summary command that'll show distributions of some of the variables, like for year, It'll tell you what the average and the median year would be, the median life expectancy, and so forth. It gives you a list of the continents. We have Africa, the Americas are lumped together, Asia, Europe, and Oceania. Those are all our continents. And then we come to one of the first big operations, and that is making some kind of a data subset. And the first command, the first verb that we're going to use is the filter verb. And in line 56, here's the first invocation of this. It means take the Gapminder data frame, and this %, greater than %, is called a pipe. And this means that we're going to take the Gapminder data frame and run it through a filter. And the filter says only allow through observations that have variable country values of Australia, my favorite country, and only Australia data rows are going to come through. Remember that there were something like 1,700 rows. Let's see, what was it? 1,704 rows. And this means we're going to ignore a lot of them, all of them, except for when the country value is Australia. And then we're going to show the first 12 of those. So let's run it. And you can see that the data frame that gets printed out from this head command are all the values for Australia. We know that they're in this continent. We have the years 1952 to 2007, life expectancy, population, and per person income. And this is a way to sort and filter your data frame. That was an example that had one condition. We wanted to look at all the observations for Australia. Our next line, line 64, says, well, we're going to look at the continent of Oceania, but for the year 1997. So this ampersand, this and sign, means that we want both of these two conditions to be met. So we want all the rows for ocean countries. It's going to be New Zealand and Australia. And we only want the year 1997. Those are going to be the rows that filter through this pipe. And then we're going to display them with the head command. And if we do that, we'll get a bunch of rows. We get one row for Australia, one row for New Zealand. There are 1997 observations. There are many observations that are other years, but we put the restriction of 1997. Notice that the logical restriction is an equals sign. That means check the logical condition that year has got to be 1997. It's not a single equals. It is an equals to invoke that logical condition. So the data set we started with had over 1,700 rows, and the data set we end with and display in the head command only has 2 rows, 6 variables. That is starting to illustrate more about the filter command. Our next example in line 70 says we are going to filter for countries that are in this list of Australia, New Zealand, and Argentina. So we're going to have those countries and also the condition that we want 1997. And so hopefully you can guess that what we're going to get when we click the evaluate button for this code block is we're going to get a data set that's going to have 3 rows, 3 countries, 1 for each country, and 6 variables, all the variables that were in the original Gapminder data set. So this is called piping, and it really is a data flow. We start on the left with the full data set. We pipe it, we run it through this filter that takes away a lot of the rows and only leaves us with 3 rows, 1 for Australia, New Zealand, and Argentina in 1987. And then this final thing is piped to a display. Line 76 is going to do another filter. We still want only 1997 rows, And this means we want all rows for continents that aren't Oceania. So this is going to take away the New Zealand and the Australia rows, and it will leave all of the others from all the other continents. Not equals is exclamation point equals. That is the way that we type a not equal sign. And if we click the green run, you'll see that, well, starting on the top, we get all the countries starting in the A's, Afghanistan down to Austria, and we get all the variables printed. Notice they're all for 1997. So we've created some data subsets, taking away rows that don't satisfy our conditions for analysis. The next thing we're going to illustrate, instead of filtering, is a select command. And so select operates on the columns or the variables. What variables do we want to include? We've always included all 6 of them up till now. Now we're going to maybe take away some. So in line 85, we're going to start with the whole Gapminder data set, and we are going to only take the variable called country. We're going to keep that one. We're going to keep the variable called year, but we're going to change its name from lowercase y. Notice the original data variable has a lowercase y for year, and we're going to change its name to an uppercase year. So this little bit right here just changes the name of the variable year. And the same thing with this next and last variable. We're going to keep life expectancy, but we're going to change its name slightly so that the first letter is an uppercase L instead of this lowercase l. And then we're going to display the data set. And that's what line 85 does. And we'll run this in a moment. I'll just show you line 87 is going to take the whole data set, and it is going to reorder everything, but it's going to put year in the front. So notice right now country is the first variable printed. What this is going to do is it's going to put year over here on the left, and then all the other variables. Everything is what that means. So let's run it. Here is the first result from line 85. We get the whole data set with just country, change name of year, change name of life expectancy. The next one is the whole data set. There's 1, 2, 3, 4, 5, 6 variables as usual, but year is now in the front because I selected year to be in the front of the data set. That's what select does. It takes what columns you want. Sometimes your data set might have over 1,000 columns, and you really only want to reasonably look like at 10 of them. So you would select the ones you want and omit the ones you don't want. And you do that through a piping operation like this. This piping stuff that you're learning about here in this video comes from the fact that you loaded in line 13 the tidyverse package. That is where the piping comes from. The ability to do this data flow. All right. Now we're going to use order. So we might want to sort according to some variables, like the biggest of something or the smallest of something. And in line 97, let's take a look at what we're doing. We're taking the Gapminder data set. We are going to only look at 1997 values. Filter means only satisfy this condition. So we're going to get rid of all the other years and only look at 1997. That's the only time this is true. We are going to only look at country, continent, and life expectancy. We're going to get rid of the other columns, the other variables. And then we're going to pipe that into an ordering or an arrange function. And we're going to arrange the data set according to life expectancy in decreasing order. This is descending or decreasing order. So, and then we're going to print it. So the result of line 97 is going to be an ordered data set according to life expectancy. Largest at the top, smallest at the bottom. And we're going to see the head of it, the first 6 rows. Line 100 and 101, That is doing something very similar, right? We have the data set. It's being piped to the filter that will only let 1997 go through. We're going to only allow country, continent, and life expectancy. That's what the select means. And then we're going to pipe it into an arrange or an order sorting according to life expectancy. But the default here is go from small to big. The previous command is big to small. This one's going to be small to big, and then we're going to display it. So let's run this little block, and you will notice that the first one is ordered from the highest life expectancy of over 80 years in Japan, and then it's followed by Hong Kong, and then we get some European countries, and then my favorite country of Australia, and these are the countries in 1997 that had the highest life expectancy. The top 6 of them, because we used the head command, which only gives 6. Unless you tell it otherwise, the default is 6. This next data set is showing the worst countries, the lowest life expectancy. In the 90s, Rwanda was in a horrible civil war, and I'm not sure all the reasons people were dying, but the life expectancy was under 40 years. Sierra Leone, under 40 years. And so we get a lot of African, and Afghanistan is always a troublesome place, and in the 90s it was also very troublesome. Life expectancy was only about 42 years. So here are the life expectancies from smallest ranging to the biggest. These are the lowest life expectancies in the data set. So sorting is frequently an important thing, and it is using the arrange function. So these examples are showing you this sequential nature of starting with the whole thing, cutting it back with a filter, cutting it back with a select, ordering, and a display. Now we work on doing some summary statistics. We're going to take the data set, and we're going to count how many rows we have for all the continents. And so we can run that. And we see a data set that lists every continent and how many rows came from each. Africa has the most, Oceania, Australia, New Zealand. I think they both had 12 observations or 12 years each, and that's why we got 24 for that. So it's counting how many rows by continent. The next one is going to take the data set, and then an important new function, grouping. We're going to group by continent, and we're going to separate out and make little separate sets by the continent, and then we're going to pipe that result into a summarize function, and summarize is going to count up this n with a parentheses, means count up how many rows are in each grouped item. So by each continent, we grouped by continent. For each continent, how many are there? And the next thing we're calculating is the number of distinct countries in that continent. So n distinct means how many distinct items by country. And so this is going to produce a little data set with 2 variables in it, the number of observations in each continent and the number of distinct countries in each continent. So we're piping a big data set, and we're going to be left with the number of rows, the number of continents, and the variables are going to be the number of observations in each continent and the number of countries. So here's the result. We have the group by continent, and here's all our continents forming the rows. And then we have the number of observations in each continent, and then the number of distinct countries that make up those observations. And notice for Oceania, it's just Australia, New Zealand. There's 2 countries. So this is illustrating summarize. Notice that in line 118, I used summarize with an S. This is the British, Australian, New Zealand spelling of summarize. And I purposely always use this one, partly because I like Australia and New Zealand, but mostly because there are other summarize functions in the R universe that use the American Z at the end. And sometimes, in my experience, this summarize with a Z gets confused with other summarize functions that use a Z, and it just avoids confusion if you always use the S. It doesn't hurt anything, and you'll probably be okay if you use the Z version of summarize. It understands both of them, but I always use the S because it avoids a function confusion, which can occur sometimes. At least it's happened to me, and it's happened to other students. So I try to always use S. Now I'm going to produce some summary statistics without groupings. So let's take a look at this. Line 127 takes the Gapminder whole data set, filters so that we only look at 1 year, and then we're going to calculate some stuff with summarize. We're going to calculate the mean life expectancy, the median life expectancy, the standard deviation, that's what the SD function does, the interquartile range, that's what the IQR function does, and then we're going to do some percentiles, quantile, the 25th percentile, Q1, and the 75th percentile, quantile at probability 0.75, and we're going to put that into a variable called Q3, because after all, it's the third quartile, and then we're going to have the number of observations counted up. So the way this is working is we're going to create an object called mean LE, and it's going to contain the result of this mean function. There's going to be a variable called median LE, med LE, and it's going to contain the result of the median function. So on the right side of all these equal signs, there are functions. And on the left side of the equal sign is going to be the object or the variable that we are giving a name to. So if you run this, you'll see we get the mean is 65 years, the median is 69.4, standard deviation, IQR, the quartiles, and how many observations do we have? We have 142 of them total. And that is the result of this code block. It is a table of summary statistics. There are other things you can ask for, and in the examples in class you'll see different ones that I can ask for, but this is the general way that it works. In line 137, what are we doing? Well, we're still looking at 1997. We're going to exclude this continent, so nothing from this continent, and then we're going to group by the rest of the continents. So this is going to create the mean and median and summary statistics grouped by continent. And the next one is going to do something very similar, except I've got some new summary stats added, the minimum and the maximum. And I'm going to rearrange the summary statistics table by decreasing descending order of life expectancy. So at the top is going to be the highest life expectancy, and at the end is going to be the continent with the lowest life expectancy. So let's run this and see what we get. The first one is the summary statistics table for the continents in the original order. We have the mean, the median, standard deviation, IQR, and the number of observations for all these continents. That's what this first set does from line 137 to 138. The next one is exactly the same thing, except, well, no, I guess it's not exactly the same thing. We have the minimum and the maximum life expectancy for each continent. We don't have the quartiles anymore, and it is ordered by life expectancy, the mean life expectancy. So notice Europe is at the top, then the Americas, then Asia, and then Africa. And it's ordered that way because we told it to do descending order by the mean life expectancy. And it's the mean life expectancy because that is the name we gave to the mean of the life expectancy, mean LE. So these are really important basic things that we're going to want you to know. how to make a summary statistics table, grouped, filtered, however you want it, and ordered however you want it. These are very important commands for you to work on. Make sure you know how to do this. Make sure you ask the instructor for help on this one. The next part of the code is to make a summary statistics table like we have done earlier, like in these set of code block. But what we're going to do is we're going to make the summary statistics table, and then we're going to save it. So notice that here we have Gapminder, and we're piping it through all of these filtering and sorting and calculating commands. But notice there is a left arrow sticking the result in an object called stats table. And in line 157, we are going to use the cable function to make a nice looking table of statistics instead of this sort of very typewriter, ugly looking table that is hard to look at and hard to understand. This is going to be a nicely formatted one. Let's go ahead and knit, and I'll show you what it turns out like when it is produced. And it takes a moment to process everything. And up it pops. And let's move it over here to the side. And let's scroll down to where we have that table being made. And it looks like it is right here. So here is the result of the cable function on our produced table. It makes a nicely formatted table as opposed to one that looks like this. And if you make a PDF file out of this, it's a beautifully formatted table. So that is the purpose of the cable function. Now we're going to work on some graphical displays. And the first one we're going to make is a dot plot like this. You've seen these in class probably. This is the distribution of life expectancy. You can see it's very clearly skewed to the left. There's a lot of countries that are pretty wealthy and healthy and wise. And there's a lot of countries that are really struggling with their life expectancy for war and political conflict and other things. So how do you make this graph? Well, let's go take a look at the code. And here we are in the dot plot. And we start by making a formatted data set that we want. We take Gapminder, we filter so that we only have 1997 rows, and we save the resulting data set in an object called DS. That's all that line 168 does, is it makes the data set we want to use to graph. In line 170, we make the dot plot, and we use the ggplot style of graphics. And we start with ggplot, the data set we're going to use. Remember, we're going to use the data set DS right here. And then we say, well, what are we going to be graphing from that data set? Well, we're going to be graphing life expectancy on the horizontal axis, X. AES means aesthetics, or what are things going to look like? Well, we're going to graph life expectancy horizontally as a distribution. And what kind of an object, what kind of a geometric object is it going to be? What kind of graph? Well, it's a dot plot. This says geom dot plot. So it's going to make a dot plot. And then we are going to label the x-axis, X label, life expectancy. And so when that is finished, you get a nice dot plot with life expectancy in years. The next code makes a histogram. It is very similar. We make the same data set in line 186, DS. And the first part of line 188, the ggplot command just says what data set are we going to use and what are we going to be graphing. Notice line 188 is exactly the same as line 179. What's different about it? Well, we're not going to do a dot plot anymore. We're going to do a histogram. So the geometry or the object we're making is going to be geom histogram. The groupings for the bars are going to be 5 years apart. That's what bin width means. And we have a similar kind of x-axis label. And so you can see again from this similar sort of thing, skewed left distribution for life expectancy. I'm not going to go over the density plot. It's sort of a summarization of a smoothed histogram. You can take a look at how that gets made. It's with the geom density. When you have groupings and you want to simultaneously have sort of histogram looking things, you can overlay them with overlaid density plots. And I've given you an example how to do that here in line 195. We make the data set. We still look at 1997. We take out the Oceania continents. There's only 2 observations for them, so we can't really make a density very well. And then for that data set, we're going to group by continent. So we're going to separate out pieces and organize it by continent. And then we're going to have a ggplot command, DS data set. What are we going to be graphing? Life expectancy. And then we're going to arrange color by continent. And that's why the densities show different colors. And then we have geom density. And then inside the parentheses for the density control, notice it says alpha 0.35. Alpha controls the ability to see through one color density to the one behind it. It's a sort of transparency measure. Alphas closer to 0 are totally transparent and see-through. Alphas that are 1 are absolutely opaque and you can't see through it at all. And in this case, I have sort of a smallish, closer to 0 number so that we can see through where all the continents are. And you can see Europe is highly concentrated up here at high life expectancy, whereas, say, Africa down here, you can see there are some African countries that have very high life expectancy, but most are quite a bit lower, like over 20 years less than, say, European countries, at least in 1997. And so this is a way to simultaneously look at distributions. This would be equivalent to looking at, say, box plots that you're going to see in a moment. But this is a little different way of doing it, and I've shown you an example. Now we're going to look at box plots. If you want to just graph one variable, you just make the data set. I want to look at 1997, and I want to look at life expectancy, and then I just do geom box plot, and it makes a vertical box plot. So this is all the countries in the world in 1997. Here's what the distribution looks like according to a box plot. My next one has box plots for 1997 again. I've taken out the 2 ocean countries and I've grouped them by continent, and you can see the box plot arrangement by continent. And the code for that is a little bit lower. Lines 217 to 220, 217 to 220 basically is for those. Lines 222 to 224, I'll just run those. 222 to 224 is going to overlay the points on the box plots, and this is preferred, and you'll see me do this during the course, hopefully. This is how I think box plots should be organized, and I've shown you the code for doing that. Because there are now 2 geometries, there's 2 kinds of objects. We have box plots and we have points. Notice that the command has a geom point and a geom box plot. If you have more objects, you have to have a geom for it. On the geom point, notice that I have jittered the horizontal position, the width, and I've jittered the height slightly so that these points don't overlay each other. Now, they're not exactly measured at the right life expectancy or exactly on the line for the continent, but by separating them, you can see their positions much better, and they don't overlay each other and hide each other. This is a really very good box plot. The next one is basically doing the same thing, except I'm using color for each continent. I don't know how important it is to use color for each continent. But in this example, I wanted to illustrate that in the first overlaid color plot, the points have an alpha of 0.25. Notice how faint they are. There's just whispers of the points. And down farther, I use an alpha of 0.8 on these, and you can see they're much darker and more opaque. You can see them better. And it's a bit of a trade-off depending on how many points you have. If you have thousands of points that you're trying to display, if you use 0.8, this will be just a blob of ink, and you won't really be able to see distinct points, and you'll need to use a smaller alpha. If you only have a few points like we do here, probably use a little bit darker colors or higher values of alpha. The next displays are for making bar graphs, and notice that the data set that you use is just filtered and grouped by continent. It is going to have one geometry, one object, a bar. And how do we make it? Well, we're going to have continent on the horizontal axis. The x variable is continent, and it understands to make the height of the bars proportional to how many observations are in each continent. And so you can see there are more countries in Africa, very few of them in Oceania, just 2. And you can see how many rows are in each continent, or in other words, how many countries are in each continent. You can make a similar graph so that the vertical axis is not the number of countries, but is a percentage. Notice the arrangement of the bars is similar, but you can read the percentage off the vertical axis. And I've done that by creating some summary statistics with Summarize. This first thing, because I've grouped by continent, this first N is going to tell me how many countries are in each continent. And then I'm using a new command called mutate, and that makes a new variable called %. And % is going to take the number of countries in each continent, N, divide by the total number of countries in the whole data set. When I sum over all the N's, that means all the countries, all the N's for every continent added together. So that's the total number of countries. So this is a fraction right here. And then by multiplying it by 100, I get a percentage. And this is the modification that you make to the geometry bar. You just say, I want the identity statistic. The vertical axis is %. I created it here, PCT. Y-axis is %. X-axis is continent. And so there's a couple of other examples making bar graphs. Here I've ordered the continents by decreasing life expectancy. And I don't really like pie graphs, but I've shown you some code for making a pie graph. And then I have some questions for you. So I would like you to modify this RMD file, add new code blocks, and add the code to do these tasks. And so you go down to the bottom of the file and make a list of 10 countries with the highest per capita GDP. That means you're going to need to make a new line right here, and then to add a code block, you go up here to insert, and you insert an R code block. And then what I'm hoping you'll do is go up earlier in this file and find some code that will assist you in making find the 10 countries with the highest per capita GDP. That is going to be real similar to what you did right right in here, lines 94 to 102, here you made increasing and decreasing lists according to life expectancy. Now I'm asking you to do it with per person GDP, GDP per capita, and so you can see that variable is called this name. So you're going to want to modify this code. So copy the piece of code from up here, paste it into your new code block right here, modify the variable names. So we want the highest per capita GDP, so I will find the code that I think I like. Highest, that's going to be this descending, so I'm going to grab these lines, copy it, go down here, and I'll paste it in here. And right now this isn't going to do exactly what I want because it is organizing by life expectancy, and I really don't want that. In fact, I'm going to take out these variable selections. I don't really need that. That's just going to arrange the variables. And I need per person GDP. So what was that variable called? That variable was called GDP per cap. So I'll copy that one. Go down here again. And I'll put it in here. I want to arrange by GDP per cap. And I want 10 of them, so that means I need to modify the head command so that it's n equals 10. And I think that should do it. Make a list of the 10 countries. And I can test that out right here by clicking, and I'll let you guys do that. That should give you some idea about how to do this practice file. And I think there'll be a small quiz on your ability to do these questions. So let me know if you have questions doing that. Before we go, let me point out that if you miss a piping, like if you miss a pipe, there's nothing connecting the filter command to the arrange command. And so if you try to run this, you'll get a red error, and it means that it was able to filter, but it never did the arrange. And so it's broken. GDP per, this thing was not found. So sometimes when you run this and you get errors like this, you're maybe not going to understand exactly what happened or what went wrong, but watch for the fact that you do have pipes in between all of the different actions. Here there is a pipe missing. Usually you have to have some punctuation like a comma or a pipe or something at the end of a row. Otherwise it'll throw an error, and that'll be something that you'll get used to. Notice at the end of this one there isn't anything, so it just ends. If I wanted to pipe this into some further thing like the cable command, I would need to just add another pipe like this, and I could do cable, and it would probably, let's see if that works, it should pipe that into a nice table. So that works. Let me know if you have questions.